Welcome to my channel. Today our device is electrocardiogram. ECG machine. An electrocardiogram, ECG, machine is a vital tool used in the field of cardiology to monitor and analyze the electrical activity of the heart. This non-invasive medical device provides valuable information about the heart's rhythm and function, aiding in the diagnosis and treatment of various cardiovascular conditions. The ECG machine records the electrical signals generated by the heart as it contracts and relaxes. It consists of multiple leads, typically attached to the patient's chest, limbs, or torso, which act as sensors to detect the electrical impulses. These signals are then transmitted to the ECG machine, which amplifies, filters, and displays the data in the form of a visual graph or waveform. By observing the ECG waveform, medical professionals can identify abnormalities in the heart's electrical activity, such as irregular rhythms, conduction delays, or signs of ischemia, reduced blood flow to the heart muscle. This information plays a crucial role in diagnosing conditions like arrhythmias, myocardial infarction, heart attack, heart failure, and various other cardiac disorders. ECG machines have evolved significantly over the years, with modern devices incorporating advanced features such as digital processing, wireless connectivity, and portable designs. These advancements have improved the accessibility and efficiency of ECG testing, allowing for faster diagnoses and remote monitoring of patients. In addition to clinical settings, ECG machines are also used during exercise stress tests, where the patient's heart is monitored while they engage in physical activity. This helps evaluate the heart's response to exertion and detect any underlying cardiovascular issues that may not be apparent during rest. An ECG machine works by detecting and measuring the electrical activity generated by the heart during each heartbeat. Here's a step-by-step explanation of how an ECG machine operates. No. 1. Electrode placement. The patient's skin needs to be prepared to ensure good electrical conductivity. Electrodes, which are small adhesive patches or metal sensors, are placed on specific locations of the patient's chest, limbs, or torso. These electrodes act as sensors to detect the electrical signals. No. 2. Signal detection. Once the electrodes are in place, they pick up the tiny electrical impulses generated by the heart. These impulses are measured in millivolts and are extremely low in amplitude. Number 3. Signal amplification. The detected electrical signals are quite weak, so the ECG machine amplifies them to make them more easily measurable. Amplification ensures that even the subtlest changes in the electrical activity of the heart can be detected and recorded. Number 4. Signal filtering. The electrical signals from the electrodes may contain unwanted noise or interference caused by movement or external factors. To obtain a clear and accurate ECG reading, the machine applies filters to remove any noise or artifacts while preserving the essential cardiac signals. No. 5. Signal conversion. The analog electrical signals are then converted into a digital format for further processing and analysis. This conversion allows the ECG machine to store and display the data in a more accessible and manipulable form. Number 6. Data display. The processed ECG data is presented as a graphical representation called an ECG waveform or ECG strip. This waveform typically consists of a series of peaks, valleys, and wave segments, each representing a specific electrical event occurring in the heart during a cardiac cycle. No. 7. Interpretation. Medical professionals analyze the ECG waveform to evaluate the heart's electrical activity. They examine the shape, duration, and intervals between different components of the waveform, such as P waves, QRS complexes, and T waves, to identify any abnormalities or patterns that may indicate cardiac conditions. No. 8. Diagnosis and reporting. Based on the observed ECG patterns and the patient's symptoms, medical practitioners can make diagnoses and develop appropriate treatment plans. ECG findings may also be compared to previous recordings or used as a reference for future assessments to monitor changes in the heart's electrical activity over time. Hello everyone. I'm excited to announce that we have a fantastic video coming up next week. We'll be continuing our series on electrocardiogram machine.